Welcome back. We are in the middle of migrating an ASP.NET app to ASP.NET Core. We've recently moved one of our controllers using Visual Studio's incremental migration extension, and we've even now used the System.Web.Adapters package in order to update a class library with System.Web dependencies to work both with our original ASP.NET app and our new ASP.NET Core app. Okay, so now let's, in this video, take a look at what we can do next by sharing session state. One of the challenges that you have in incremental migration is that you do have two separate applications running on your servers. You've got the original ASP.NET app, which is serving any requests that go to endpoints that haven't been migrated yet, and you have the ASP.NET Core app, which is serving requests which go to migrated endpoints. We've seen that working already in this video series, including sharing class libraries. But a place where it can get tricky is if there's state in your app that needs to be shared between these. And a common one is if you store session items. Session state, of course, is specific to the user's session, but it also is specific to the application. So out of the box, if a user does something that causes a session item to be written in the ASP.NET app, the ASP.NET Core app won't be aware of that, and vice versa. So if we take a look at our application, one of the things we haven't been able to uncomment yet is this part of our layout page where we get some information out of our session state, which will get us the two different session items, one that's called machine name and one that's called session start time. Now, both of these items are written as the session is created in the ASP.NET app. If we come over there and look in our global ASAX, you can see we have a session start method that sets both of these session items so that they're available later for diagnostic purposes. And then our layout page just displays them in a footer so that they're there so that we can look and see when the session started and what machine is serving the request. Now, these APIs are available. All we need to do is add a using System.Web up here, because remember, we have the System.Web.Adapters that will make common System.Web APIs available both to ASP.NET Core, .NET 6, .NET 7 projects, and a .NET Standard. So by just adding this System.Web, we're now able to use HTTP context current session, and that's going to work. HTML string just got moved to a new namespace in ASP.NET Core, so we're going to add a using for that. And this code will now build. It won't yet run, though, because right now, in the System.Web.Adapters, when you call HTTP context.current session, if you try to get session for an HTTP context, we need to have a little configuration to say where to get that session information from. And there's two options. You can configure session in the System.Web.Adapters to come from the ASP.NET Core session state and just sort of wrap it with these APIs that look like the same shape as the old System.Web ones. So you could set that up. So then we would read and write the ASP.NET Core apps session by using System.Web HTTP context session APIs. Or you can configure the System.Web.Adapters session APIs to use a remote apps session state. And that's what we're going to do here, because we're going to set it up to get session information from the ASP.NET app. So when the user reads session information, the application, the ASP.NET Core app, will go and get that session information from the ASP.NET app so that it's getting the same session information that would be retrieved if the user had gone to a different endpoint that was served by ASP.NET instead of ASP.NET Core. Similarly, if the user writes any session through these shim APIs, it will be written back to the ASP.NET app. So there's one source of truth for session state, and that's the ASP.NET app. And the ASP.NET Core app can be configured to just depend on that. It also does include all of the same locking mechanics as ASP.NET has, so you'll get the same behavior you've come to expect in your ASP.NET app in your ASP.NET Core app, which makes the migration a lot easier. So we've sort of uncommented all this. Now we need to make sure we've set it up to work. So let's jump in and show how we do that. The first thing we're going to do is look and make sure that we have a reference to Microsoft ASP.NET Core System.Web.Adapters core services. This is the NuGet package that has the APIs needed to configure an ASP.NET Core app to use things like remote state and shared session. So we have that already there. So now we can go into program.cs, and we're going to have to configure a few services. The first thing we're going to do is where we have this add System.Web.Adapters, we're going to go ahead and update this to also say we want to add a remote app client. So we're configuring our ASP.NET Core app to be a client that can go and communicate with an ASP.NET server for sharing information. Now, I know it's a little bit weird to use the term client for an ASP.NET Core app since that is a server itself, but when you think about the relationship between the two ASP.NET applications, the ASP.NET Core one works as the client here because it's retrieving information and it's initiating the requests to the ASP.NET app, which is serving or storing session state. So we're going to say that we're setting up a client, and we have some configuration we can do here. First, we're going to have to set the remote app URL where we go. So when we go and get information from this remote app, where do we get it from? Okay, so we're going to say that remote app URL equals a new URL or a new URI, and we're actually going to use the YARP proxies configuration because we already have the URL of our ASP.NET app set up as something that the YARP proxy will fall back to. We're going to use that same configuration value as the URL that we're going to redirect to for remote app operations. Also, we want to keep this secure, so we need to have some sort of shared key that's common between our ASP.NET and ASP.NET Core apps so that, let's see, does this need to be, yeah, here we go. So we've got this API key that we're setting up so that we can have a common shared key, a shared secret between the ASP.NET app and the ASP.NET Core app, so that when the ASP.NET Core app requests some shared information like shared session state or shared authentication decisions, it can present this key as a way to validate itself as a trusted caller, because this information is going to be made available on endpoints in the ASP.NET app, and we don't want any other callers to be able to access them directly outside of the ASP.NET Core apps that we've authorized. Okay? Now, we do need to make sure that we have a remote app API key in our app settings so that we can read that from configuration. So I'm going to come over here. Remote app API key in this setup is just a GUID string. It needs to be, the dashes are optional, but you basically just generate a random GUID to make sure that you have a secure shared secret. Okay, so now at this point, we've set up our ASP.NET Core app to be able to communicate with the ASP.NET app. So now let's go over to our ASP.NET app, and we're going to make just a few changes there for it to be able to receive those requests. So if we go into our global ASAX, we're going to do something very similar. This is going to look a lot like what we did before. Here in our application start, we are going to say System.Web.Adapters. Let's see. Configuration. We need to add a NuGet package, right? Remember how we had that core services NuGet package in our ASP.NET Core app? We need to have the equivalent package for .NET Framework usage in our ASP.NET app. So go to Manage NuGet Packages. We are going to browse for Microsoft ASP.NET Core System.Web.Adapters Framework Services. So this is a package targeting .NET Framework that adds functionality that allows the ASP.NET app to share some state with other ASP.NET Core apps that connect to it. So we're adding this package. Okay, now that that's added, we can come back here in our global ASX, and now this type exists. Okay, and then from here, we add System.Web.Adapters for this application, and now it's going to look very similar. We add remote app server in this case, and we have options to configure for the server, and here are even a little bit simpler. The only thing we need to add is we need to specify the API key. Okay. And then we'll go into our web config for this application and make sure that we have set the API key here so that it can be read. Now, in practice, you would probably actually be reading this API key from something like like an Azure Key Vault or something like that. But the point is that you have this shared secret between the two apps so that they can securely communicate. Okay, so now we also will check one other thing. This should be set up automatically by the incremental migration tooling, but ensure that you have a module for System.Web.Adapters. This is the module that is going to expose additional endpoints for things like sharing session state or sharing authentication. It's already set up, so that's good to go. So now at this point, our ASP.NET Core app knows how to communicate back to the ASP.NET app outside of just the very simple YARP proxy, and instead it can make these sort of more scenario-specific calls to get shared state. So now we need to do a little more configuration to actually set it up to share session state in particular. So coming back to our program.cs, let's go ahead and do that. The first thing we need to do is we need to explain how to serialize the session state that gets shared between the two apps. And unlike the ASP.NET app, we're going to actually share this in a strongly typed way, serializing it with a JSON serializer, and that's for security reasons. So we add a JSON session serializer, and inside here, because we want to share things in a secure, strongly typed way, we do need to register the different session items that will be sent back and forth between the two apps and what types they are so that we know how to serialize them properly. In ASP.NET, this wasn't necessary. You could have just serialized them using like the binary formatter, but that's not a secure way to serialize. So for security's sake, we're specifying that we're going to have a session item called machine name that is of type string, a session start time that's of type date time, and you can even have custom compound types as long as they're serializable. We have something called demo item, which we're going to use on our session endpoint specifically, and this is of type session demo model. So we register these as session items that we need to know how to serialize, and then we are also going to add a session client. So this adds some services to the DI container that will be able to actually make the call back to the ASP.NET app to request or to set these session items. Okay? Then finally, we need to, for performance reasons, specify which endpoints actually get session state, because the way this works is that when the ASP.NET Core app serves a request, it's going to go and get the session items first, then it's going to serve the request. Then if there's anything that changes as a result of serving that request, it will then write that session state. So it involves this hop back to the ASP.NET app, which could have performance implications. So you really only want to do that for endpoints that need the shared session information. So what needs to happen is either we need to go to each of our endpoints or each of our controllers that care about session, and we add this session attribute. And this informs that, service that when we serve this request, we need to have shared session available. If we don't have it, we don't do that request back to the ASP.NET app. We get a small perf win, but now we can't use shared session. The other option, though, is because in this case, we're actually using session in our layout page, we're going to use it everywhere, so every single endpoint is going to need it. So rather than add session attributes all over the place, we can actually come back down here to where we define our route, and we can say require System.Web.Adapter session. And this is just going to inform our ASP.NET Core app that all of our endpoints that we get to through this route mapping are going to have shared session enabled. Okay, so now we are ready on the ASP.NET Core side. So let's go ahead and jump over to the ASP.NET app again and get this one configured to serve that session information. Okay, and the way that we're going to do that is again going to look very familiar. So what we need to do is we need to configure how we're going to serialize the session information so that that's common between the two applications. So we're going to add our JSON session serializer. We're going to register the keys again, give the types, and then, as before, we are going to do an add session server. Now what this does is it actually will enable new modules so that the ASP.NET app will listen on dedicated endpoints for requests from the ASP.NET Core app to say that it needs session information or that it's setting session information. And so at this point, we should be able to use our little footer, which is in the layout page, and have it work both places. So let's go ahead and test that out. We'll see if I missed anything. Go ahead and build, make sure that this all builds. And, you know, knock on wood, we should be able to have the session information available to both of the apps in our solution, both the ASP.NET app and the ASP.NET Core app. So I'll go ahead and launch this, and we will see what happens. Okay. Here's our app. And now if we come down here, not only do we have the user agent, but in this page served by the catalog controller, we're getting the machine name and the session start time right here in our footer. So we know that we are reading session items that were written by the ASP.NET app. So that's working. One last thing we can do here. We do have in our original app this ASP.NET session controller, which its whole purpose is it allows the user to set and read some string and int session items. And I have this here for demo purposes, but let's go ahead and migrate this because it should be super easy now. We're going to say migrate controller. We're migrating the views that go with it, the models that it cares about. So we click migrate selection. Okay, and now in our ASP.NET Core app, we have that same session controller. It's here. Now, notice that we are using http://context.session, which is a System.Web-ism, but because we are using the System.Web.Adapters, we can just say using System.Web, and this is going to continue to work here, the same as before. Okay, so we've got that. And actually, I see it's still underlined. I think the problem is because we actually have session coming from two different places. So what I'm going to do here is, because we need both Microsoft ASP.NET Core and System.Web APIs here, I'm just going to fully qualify this like so. Web.http://context.session. And that should work. Let's see. We'll build this and see. No, it's still not happy with it. Why not? Oh, right. Okay, so of course this is just the type. We need an instance of it. So the System.Web.Adapters are set up such that you can actually cast back and forth between the types. So we can do something like, let's see, what's it called here? HTTP context. Yeah. So we can take the HTTP context property on our ASP.NET Core controller, and we can cast it to a System.Web HTTP context so that we can use System.Web APIs like .session with it. Okay, so this is going to look like so. Oops. Okay. Why is this not happy? Let's see if I build it. Okay, it builds. I think IntelliSense just hasn't caught up. Cool. Now, normally this would be all we'd have to do, and now this ASP.NET session page would be served by ASP.NET Core instead of by ASP.NET. But I think a really cool demo is to be able to see both of them working at the same time. So I'm actually going to change this to be ASP.NET Core Session Controller. I'll change the name of the controller file too. And this is not something you would do in a typical migration scenario. And then we can actually rename the views folder. But in this case, for demo purposes, I'm actually migrating an ASP.NET controller to a differently named ASP.NET Core controller so that they can both be available in the app at the same time. And we can see how setting a session in one of them makes it work in the other one. Okay, so at this point, just checking my notes here, I think that should be all we need to do. There is one other small fix I think we need here. That's all okay. Because we updated eShopLegacy.com into target .NET Standard, and it has this dependency on system component model annotations. Since we're going to be using this on ASP.NET, we might need to add a reference to it directly, but let's try launch our app and actually see what happens here, because this may be all we need. Let's test it out. Okay, it's launching. Okay, here's our app. Now I think when we go to session, when we try and set session state, it's going to need that component model annotations library. So we might need to add that, but let's test that. Let's say we're going to update session. Yes, it looks, actually maybe that worked. Okay, so here, actually maybe it did work. So we've set session. So our int item is 123, our string item is AAA, and this is in ASP.NET, right? Not ASP.NET Core. But if we navigate instead to ASP.NET Core session, okay, we do need to add that. Let's add that real fast. So I'm going to, so we're going to go to our ASP.NET app, manage NuGet packages. We need to add a reference to system.componentModel.annotations, just because it's not transitively picking this up from the .NET Standard library that's pulling it in. So here it is. I think we were just using version 5 over there, so we'll add version 5. And I know from doing this before that there is a conflict where we need to add a binding redirect for this as well. So I'm going to come down into my web config and make sure that I've added this. And this is just a little bit of the friction of using new style, SDK style projects with package reference style NuGet packages alongside an old style CS proj. You run into this sort of temporarily as you're doing migration work sometimes, but eventually you'll move away so that everything's on the new SDK style project and it gets a lot simpler. But let's go ahead and try this one more time and see if it works. At this point, it should. So we will test it out. Okay, it's launching. Oh, I had this enabled from before. Let's turn that off and try that again. Okay, here we go. Launching our app. Okay, our app is running. We see that we are getting shared session state right here. But let's go ahead and test out the session endpoints. Okay, so we will, on the ASP.NET session endpoint, this is ASP.NET session, we're going to set the integer session item to 123 and the string session item to A. We'll update this. So now if we come back here, those items are stored in our session. But if we go to the ASP.NET Core session, it didn't find the index, it says. Let's double check that that's correct. I named the folder wrong. I said ASP.NET Session Core instead of ASP.NET Core Session. Okay, one more time. This time it really ought to work. We're going to launch this and test it again. This was just because I renamed the ASP.NET Core version of the controller so that they could both exist side by side, and I didn't rename the view folder to match properly. So I've fixed that, and now it should work. Okay, we've got our app. We're going to go to the ASP.NET session endpoint. We're going to store something here. Okay, now from there I'm going to go to ASP.NET Core session. And this is the ASP.NET Core endpoint, but it's showing us that same session information. And we can update this. And now this is ASP.NET Core Session that updated it. But if we go back to our main page and then we go back to Session, you can see that we have the updated values. So we're actually able to both read and write session state from the ASP.NET Core app or the ASP.NET app and have them both see the updates made by the other one.